Imagine being sucked into a void so dense, not even light can escape. It's a pretty mind-blowing concept. And this is exactly what black holes are. Regions in space where the gravitational pull is so strong, nothing, including light, can escape once it gets too close. The idea of a body in space so massive that not even light can escape its gravitational pull has been around for centuries. But it wasn't until the 20th century that we started to really understand what black holes are and how they work. So let's dive in. You might be wondering, what exactly is gravity? Well, it's a force that attracts two objects with mass towards each other, like the Earth and you. The Earth is pulling you towards its center. That's why you don't float off into space when you're standing on its surface. But when it comes to black holes, their gravity is so strong, it warps the fabric of space and time around them. This fabric is called space-time, and it's basically a combination of the three dimensions we're familiar with: length, width, and depth, plus a fourth dimension, time. So when something with a lot of mass, like a black hole, is introduced into space-time, it creates a kind of dent or curvature that affects how other objects move through space and time. Now, when we talk about the point of no return around a black hole, we're referring to something called the event horizon. Once you cross the event horizon, you're trapped and will eventually get pulled towards the center of the black hole, where the gravity is so strong it becomes infinite. This point is called the singularity. But here's the thing, the event horizon isn't like a physical boundary. It's more like a mathematical concept, a line that marks the point where the gravitational pull becomes so strong, escape is impossible. And it's not just objects with mass that get affected. Time itself starts to slow down near a black hole due to a phenomenon called gravitational time dilation. This means that time passes differently for someone near a black hole compared to someone who is farther away. The closer you are to the black hole, the slower time moves. It's a pretty weird concept to wrap your head around, but it's been confirmed by scientists using extremely precise clocks, and it has some pretty interesting implications. For example, if you were to place two clocks side by side, one near a black hole and the other far away, they would start to show different times. The clock near the black hole would appear to be ticking slower compared to the clock that's farther away, and this effect becomes more pronounced the closer you get to the event horizon. Now, you might be wondering, how do black holes even form in the first place? Well, it's usually the result of a massive star collapsing in on itself. When a star runs out of fuel, it can no longer support its own weight, and it collapses, causing a massive amount of matter to be compressed into an incredibly small space, creating an intense gravitational field. This process is called a supernova, and it's an incredibly powerful explosion that can be seen from millions of light years away. But what's left behind is a black hole with a gravitational pull so strong it warps the fabric of space-time and affects the motion of any object that gets too close. The study of black holes is still a relatively new field, and scientists are still trying to understand the intricacies of these mysterious objects. But what we do know is that they play a crucial role in the evolution of the universe and have some pretty interesting effects on the surrounding space. Black holes come in a range of sizes, from small stellar mass black holes, formed from the collapse of individual stars, to supermassive black holes, found at the centers of galaxies, with masses millions or even billions of times that of the Sun. The biggest black hole discovered so far has a mass of approximately 40 billion times that of the Sun, and is located at the center of a galaxy called Messier 87, or M87 for short. It's a truly massive object, and its event horizon is roughly the size of our entire solar system. The discovery of supermassive black holes has led scientists to believe that these objects may have played a key role in the formation and evolution of galaxies by regulating the growth of stars and shaping the overall structure of the galaxy. And that's a topic we'll explore in more depth as we continue to explore the mysteries of black holes. So let's dive deeper into how supermassive black holes can affect the growth of stars and the overall structure of a galaxy. Essentially, when a supermassive black hole is actively pulling in material, it can heat up the surrounding gas and dust, making it more difficult for new stars to form. This is because the energy released by the black hole can evaporate the gas and dust, kind of like how a strong wind can blow away the leaves on a tree. On the other hand, when the black hole is not actively feeding, the gas and dust can cool down and collapse, allowing new stars to form. It's a delicate balance, and scientists think that this balance may have played a crucial role in shaping the galaxies we see today. One of the ways scientists study this balance is by looking at the distribution of stars and gas within a galaxy. They can use powerful telescopes to observe the light coming from the stars and gas, and from that they can infer how the galaxy has evolved over time. It's a bit like looking at a tree ring where you can see the different layers of growth and determine how the tree has changed over the years. By studying the distribution of stars and gas, scientists can learn more about how the supermassive black hole at the center of the galaxy has influenced its growth and evolution. Another important aspect of supermassive black holes is their relationship with the surrounding galaxy. Scientists have found that the mass of the supermassive black hole is directly related to the mass of the galaxy it resides in. This is known as the black hole galaxy scaling relation, and it suggests that the growth of the black hole and the growth of the galaxy are closely tied. It's not entirely clear why this relationship exists, but scientists think it may have something to do with the way that gas and dust are funneled towards the center of the galaxy, where the black hole resides. As the galaxy grows and evolves, it's possible that the black hole grows along with it, kind of like how a plant grows as it absorbs more nutrients and water. The study of supermassive black holes has also led to some interesting insights into the early universe. Because these objects are so massive, they can be seen from very far away, and scientists can use them as kind of cosmic lighthouses to study the universe in its early stages. By looking at the light coming from supermassive black holes, scientists can learn more about the conditions in the universe when it was still very young, and how it has evolved over time. It's a bit like looking at an old photograph, where you can see how things used to be, and how they've changed over the years. By studying supermassive black holes, scientists can gain a better understanding of the universe's history and how it has become the complex and dynamic place we see today. As scientists continue to study supermassive black holes, they're also learning more about the role they play in shaping the surrounding galaxy. For example, some galaxies have been found to have supermassive black holes that are actively jetting out material, kind of like a cosmic fountain. These jets can be incredibly powerful, and they can affect the surrounding gas and dust, shaping the galaxy's structure and influencing the growth of new stars. It's a complex and dynamic process, and scientists are still working to understand all the details, but it's clear that supermassive black holes play a crucial role in the evolution of galaxies, and that's something we'll continue to explore as we learn more about these mysterious objects. So let's dive a bit deeper into the ways that supermassive black holes can impact their surroundings, because it's really fascinating stuff. One of the most interesting effects is the way they can regulate the growth of stars in their galaxy. It's kind of like they're controlling the thermostat, making sure things don't get too out of hand. When a supermassive black hole is actively sucking in material, it can heat up the surrounding gas and dust, making it harder for new stars to form. This is known as feedback, and it's a crucial process that helps to shape the galaxy's evolution. But that's not all. Supermassive black holes can also affect the motion of stars and other objects in their galaxy, warping the fabric of space and time around them. This is where things get really mind-bending. According to Einstein's theory of general relativity, massive objects like black holes warp the space around them, creating a gravitational field that affects everything that gets too close. It's like a cosmic game of gravitational tug-of-war. The closer you get to the black hole, the stronger the gravitational pull, and the more extreme the effects become. It's a truly awe-inspiring phenomenon. Now, you might be wondering, what happens if you get too close to a supermassive black hole? Well, let's just say it's not a good idea. The gravity is so strong that it would stretch and squeeze you like Play-Doh, a phenomenon known as spaghettification. It's a pretty wild concept. But don't worry. This only happens if you get really, really close to the black hole. And even then, it's not like you'd feel anything because the gravity would be so strong that it would essentially rip you apart at the molecular level. It's a pretty intense way to go. Despite the dangers, scientists are really interested in studying supermassive black holes up close because they offer a unique window into the extreme physics of the universe. It's like having a front-row seat to the most epic cosmic spectacle. By observing the effects of these black holes on their surroundings, researchers can learn more about the fundamental laws of physics and how they govern the behavior of matter and energy in the most extreme environments. It's a truly fascinating area of study. As we continue to explore the mysteries of supermassive black holes, we're constantly reminded of just how much we still have to learn. It's a humbling experience, but also a thrilling one. The universe is full of secrets, and uncovering them is a journey that's full of twists and turns, but also full of incredible discoveries, and that's what makes it so exciting. So, if you're ready to keep exploring the wonders of the cosmos, be sure to check out our next video where we'll be delving into the mysteries of dark matter and the role it plays in shaping the universe as we know it.